recording now? Yeah. Cool. Okay, so I'm going to repeat again one more time. The people on the left, that screen will not work. So if you can, and you have internet, I've put the URL to the slides here so that you can pre-download them. Good luck with that. All right. So the agenda for this talk, if you have any questions at any time, please ask them. I can go a lot deeper for all of these slides, but I just don't know what everyone's interested in and what you guys want to talk about. Someone up front remind me to repeat the question, otherwise I will not do it. So we're going to go over general terms. This talk is scalability, reliability, and performance in that order. We're going to go over strategies and tactics, so like general ways that we can make these things happen, and then specifically what we can do, what we do at ZipRecruiter. Anybody else over here want to look at that URL? Anyone? I'll give you 30 seconds. Could I read it? Yeah. fREW as in X-ray .github.io/SRP as in scalability, reliability, performance --@-zip. And apologies in advance, these slides I can't zoom in or zoom out, so if the fonts are too small, there's nothing I can do. Software. Okay, I'm going to get started. We're waiting for Nathan. Okay, so quick caveat. I'm just going to read this quote. You can prematurely optimize maintainability, flexibility, security, and robustness just like you can performance. This is John Carmack. He also said at one point that if you over-optimize some code, it can be difficult, but you can undo that. If you make your code overly flexible early, that is much, much harder to undo. It makes your eyes bleed. So all that to say, you know, we're going to be talking about robustness and scalability in this talk, and there's no right answers. A lot of what we do at Zip would not apply to a company with, say, a single web server, or you know. So anyway, just take a lot of this with just keep that in mind. All right, so defining our terms. Scalability. I like to think of scalability as resource saturation. So if you were using 1% of server resources, but you can't get more servers, like if you were a turnkey shop or something, you could scale 100x. But that's like you're using 1% CPU, 1% memory, 1% disk, 1% bandwidth. I'd be surprised if you actually had measured all those things enough to be confident of that. And in this kind of situation, scalability and performance are about the same thing. Because if you make your code more performant, you can scale more. Again, that's like at my last job, we sold a server that customers installed on site. If we made our code more performant, they could run more web workers or whatever. If you're using 100% of all the resources on your host, but you can get as many servers as you want, then you could theoretically scale infinitely. But that's, I would say that that's unlikely. Chances are you have other bottlenecks that you don't know about, like your database. If you're using a database, it probably can't scale infinitely. So measure everything. So some strategies and tactics for this. You can always theoretically increase total resources. So at my last job, when we had a turnkey server, we could run more plaque workers. You know, and so when you have more plaque workers, you can service more requests in parallel, or you can decrease usage. So you can use less memory. I'll talk more about that. Or use Perl. I actually don't know if that works, but you know, use a more efficient framework. Okay, reliability. That's like error percentage, right? So if you got all 200s and like legitimately, not just like you said it was a 200, but it was an actual error in your backend, that would be like you were 100% reliable. Like every single web request got served and you didn't have any problems. I would say, you know, robustness to errors is a general strategy. We have lots of ways to do that in Perl. Tests is something that I think a lot of us do, and the idea there is that, you know, you do a test and you can say, I'm pretty sure this code works. Timeouts, we use timeouts a lot. We'll talk a lot about that later. Retries, if you were talking to a third-party service, sometimes things can be flaky, so you try again. And then also be perfect. And I actually think that that's actually really bad advice when it comes to reliability, because human beings are not perfect and will not be perfect and are bound to make mistakes. And I actually think that a good, if you're only to take away a couple things from this talk, one of them would be that if your reliability is dependent on people not making mistakes, you will go down. I have this IIS anecdote. An example of a not reliable system. At my last job, we actually used to use IIS to host our web server for Perl, actual Perl. And anytime we would, I can't remember if it was either warn or print to standard error, but one of those two events would cause IIS to go down. And not just for that web worker, and not just for that request. The entire server would get corrupted. And like an engineer had to go in and like fix it. So like we had all these like no warnings everywhere, and like you had to like comment out all the code that had like a warn or print standard error. So that's an example of a not reliable system, because it's really easy to actually accidentally have warnings. And then performance. This is how quickly you can service a request or a query. So for a web server, you might say 1,000 requests per second. For a database, you might say 30,000 requests per second. These are coarse. You can get a lot more complicated with this, like how well do you handle concurrency, but this is just, you know, high-level terms. There's lots of ways to make this better. At ZipRecruiter, we are willing to trade some performance for scalability. MapReduce, if you know what that is, that does that kind of thing. But generally, for us, we would rather be slightly slower, but able to have a lot more servers so that we can handle more customers. And then I've got this list. This is from, I think, Brendan Gregg, who works at Netflix now, of ways that you can increase performance. I like it because it's pretty easy to remember, and just like, if you want to make something faster, just don't do that thing. That's the best way. People often go straight to like making it faster, but don't do it if you can avoid it. Or do it, but don't do it again. It's like you've got some kind of cache that, like a lazy builder or something. Do it less, so you know you've got some kind of like OCRing, and you don't have to do it for every customer request, just the ones that like get past some point. Anyway, if you find the slides, if you can get to them, the source is a great talk about improving performance. Anyway, so all right. I really wanted to have a graph of business growth here, but I could not make that happen for secret reasons. But basically, at ZipRecruiter, we found that in the middle of last year, if we had continued to grow our business at the rate that it was growing and did not do anything to improve scalability, we would have hit a wall at our database. And our database was the second largest instance that can run on Amazon. So this is a big, big server. It's not like a VM on a bunch of others. Like this was taking up the entire physical machine. And so for us, we had to make our service more scalable. And I just think that that's a key insight that you need to be aware of in certain kinds of businesses. This is not always the case, but for us it was. So this was almost a live or die project. We had to improve the scalability of our software. So at ZipRecruiter, the first thing that happened when our CTO joined, Craig Ogg, was we had to get rid of our capacity caches. So let's say you have a web server and it's doing servicing something like, I don't know, Uber rides, I don't know, whatever. And you can do 1 request per second, not very many. But you add a cache, and now you can do 1,000 requests per second. It's like, awesome, we can serve 1,000 times the amount of users. The time passes, and the cache gets blown. Anybody know what happens? The site goes down. The whole site goes down. And the problem is that you've had this invisible resource that is required for your system to function, not just perform, and chances are it's not well monitored, it's not well tested, and you know, this is actually a lot more likely than you think, because you don't immediately go from 1 request per second to 1,000 requests per second. You more likely slowly increase the amount of things that are hitting your server. It wasn't actually as slow as 1 request per second, but still, even if it's one request for half a second, or that's not what I mean, like 300 requests per second, you can still get in this situation because eventually you're going to have more users than you can serve. And so at ZipRecruiter, we think we've taken a more balanced solution. We say you cannot have capacity caches, which make it so that your server can even. You can have latency caches, where if the cache is gone, the system works, but it's a little slower. But go ahead, Jim.
Can you define the term latency cache?
Yeah. So I mean, sort of. So, pardon? Thank you. So Jim asked if I could define latency cache versus capacity cache. It's a fuzzy line. It's almost a sort of like no true Scotsman, but basically, if your cache goes down and your server goes down, it's a capacity cache because it increases your capacity, the amount that you can serve. Whereas a latency cache simply makes your code faster. It could be anything. It could be the results of a complicated computation. It could be a database query. It could, like, it is completely arbitrary.
So the dividing line is if the cache is blown, the site goes down.
Right. He said the dividing line is if the cache is blown, your site goes down. And I would say yes. Yes, I agree.
Did it have to be all?
I don't think so. Did this happen? No, this didn't happen. Our CTO is fairly seasoned, and so he was just terrified that it would. And we were really, when this happened, we were depending on caches a lot. There's something that I say, I thought that Dominus said it, but he didn't, that like if you want to make your code faster, add a cache. If you want to fix a bug, remove the cache. So anyway, it was just we needed to make that code faster, the code that needed to be cached. I'm not going to go into that. Okay, so timeouts and reapers. Anybody think that these things sound familiar? SendGrid is always fast. DynamoDB is always fast. S3 is always fast. Everything needs a timeout. Okay? Does anybody remember in February when S3 went down? It was a big deal, right? If you don't have a timeout to cut off those long-running operations, you're holding your server hostage on these third-party APIs. And everyone uses these third-party APIs, or even your own database. Everything should have a timeout, including your database. But sometimes, especially in Perl, timeouts are kind of unreliable because they're handled sort of in Perl code. So if you get a timeout while you're waiting on a C system call, you may block forever. This often happens with DNS because DNS tends to be not asynchronous. So we have another thing called a reaper. We have a few reapers at ZipRecruiter, but I'll go over two. One is what we call our MySQL reaper. And what it does is it does a query to look at the current running, well, it does a query to see the current running queries, basically. And all of our everything that goes through DBI uses a special module, which I have a link to in the bottom of this slide that's on my blog, where we prefix every query with some JSON. And so when we do that query to get the list of running queries, we can look at the JSON and say, is this a get? Is it a post? Is it a batch job? Etc. And then what we can do is we can say, okay, that's been running longer than 5 seconds. It's a get, terminate it. Because we don't allow web requests to take longer than 5 seconds, especially at the database layer. We do the same thing for Plaque. If you are aware, there's a thing called a scoreboard, which is where you can go in and look at your server status and see which workers are serving which request. We actually have another process that reads that scoreboard and looks at the URLs being serviced and what method they're doing, and it says, it's more complicated than this, but the coarse-grained version is, if it's a get and it's taken longer than 5 seconds, terminate it. And if it's a post, we give it longer, in the theory that that is more important. That's actually complicated. It's kind of hard to get that race-free. The thing being terminated has to be complicit. It basically has to check itself to see if it should have been terminated, and then it logs and exits. But these reapers are a big deal. So these three links give you all the details. This is a normal, so we reap stuff all the time because nothing's reliable, right? Nothing's perfectly reliable. So this is examples of a report where these are things that have been reaped. This is a normal day. This is when S3 went down. Our site didn't go down, and it is entirely because we had the Reaper. If we didn't have the Reaper, I suspect we would have gone down in a matter of minutes, maybe 5, maybe 10, because all of our workers would have been blocking on some job seeker uploading a resume. So this is a big deal. We could have done better because we didn't have timeouts on S3 uploads, but the Reaper was a good suspenders to our belt.
Was your site broken partially from last year?
Yeah, so Henry asked if our site was broken. Absolutely. I mean, there's nothing you can do when a service like that goes down. But our site still partially worked. Basically, people couldn't upload new resumes, anything that had to work with S3. We should have, go ahead. Presumably, our site could tell us that S3 was broken?
No.
Oh, it could tell the users. Yeah, I mean, that's true. That's true. And it didn't. They probably got a white page or an error. And today, it probably still wouldn't. I suspect that the users noticed because the whole internet was kind of on fire. But nonetheless, we could have done better. And for what it's worth, I actually have a blog post about this, which I didn't link to because I didn't think about it. Like, we noticed within minutes when it went down because, like, it's like a fundamental service. It's like almost as bad as if your database went down. Okay, so who here has heard of Aurora? A few people. So Aurora is a closed source fork of MySQL that Amazon made. The whole goal is to make it more scalable. Basically what it does is it uses a, it actually chops off MySQL under the engine and uses block level technologies to do the scaling instead of row or logical level. So the replication is handled kind of the way that you might think S3 might be. So the interesting thing that we found was when we switched to Aurora, or actually this was before, but ZipRecruiter, unlike most companies that I've worked at, our database was actually CPU bound, not IO bound. And so that actually made it much harder for us to figure out how to scale our site, because if you look at a query and you look at statistics, we don't track how much CPU a query uses. That's really hard. And so this was a really difficult project trying to get to where we were comfortable. One thing that's nice about Aurora is if you're familiar with MySQL and adding read followers, it basically, you have to tell the read follower to re-execute all the SQL that the master had executed. You might be able to cut off some of that, but at some point you have to connect to the master and start re-executing. For us, that meant 15 to 18 hours of running another MySQL instance. For Aurora, it takes like 2 minutes. It's like really fast because it's actually using the same block store for the storage. And for us, we were using the second largest instance. I think I mentioned this before. Second largest instance MySQL could run on AWS, and we were over half of the total I/O used. So we were going to run into a wall there anyway. So like on an average day, we were using more than half of our database with respect to I/O, and then also CPU was bound. So I'm not going to go into that. So here's an example of where we are now, where you can see the readers, and there's 3 of them. We try to keep them under 10%, the CPU, because that's our limiting factor, and we want to always have a factor of 10 growth, just in case. Like, I don't know if you noticed, but we like accidentally got an ad during the baseball game. What's that? The World Series, yes. In the 9th inning. This was an accident, sort of. And we didn't even notice. And if we had not done this, we may have noticed. And then this is the writer. We always want the writer to be less than the reader, but during low times, they tend to be closer. When we're getting more access, the reader gets much more volume. The RW splitter, originally called Freaky Friday, was Craig Ogg, this is his idea, Aaron Deltac, aka Bluefeet, implemented the actual working version. I started with something and it like didn't work at all, and then I went on vacation. Basically, I thought this was like a brilliant idea. We've all seen the thing where in big data, you search for something, or you like add something to your account, and then you search for it, and it's not there, and then it's there 5 minutes later. And there's like some kind of replication lag there. So what our CTO came up with is a system where we would actually track the user does a write, which we know through our ORM. They go through a write method, and then we put the timestamp of the write in a cookie. And when the user comes to the site, they send the cookie, and we compare the timestamp to what we think the lag is on the read followers. And so then we can say, should we go to a read follower or not? If they just did a write, we're going to send them to the master. And then our engineers don't have to think about replication when they're working on making code more scalable. We actually have this sort of built in. Trying to think if there's anything else interesting there. Any questions about that? That uses DBIX class and Catalyst. I think it'd be really cool to open source, but it's really like in the guts of everything. So like while ZipRecruiter would be happy to open source it, just factoring it out is very difficult because the storage layer is not really pluggable. We have our own storage layer. We've done a couple table level refactors in MySQL. One simple example is we had this table. So quiz in ZipRecruiter quiz is jobs. So if you're not familiar with our business model, you want to hire someone, so you post a job on our site, and then we show it to a bunch of people through lots of different boards. And the description is what you would expect. Nothing surprising there. So we have like a ton of rows here, like millions. And the description is a text field, and it's really big, and there tend to be duplicates. And so and if you're familiar with DBIX class, you usually get all the columns. DBIX class lets you opt out of columns, but engineers don't think about that because you have to like remember, am I going to use this column? And honestly, I wouldn't judge anyone for that because it's just how you tend to use DBIX class. And so what we did was we actually factored that column out into a separate table and made it so that the description method would do a query, and then in the places where we knew we were using it, we prefetched it. And that actually helped a lot because in MySQL and Aurora, your performance tends to bottleneck on the InnoDB buffer cache. Basically, the way, it's kind of in the weeds. If anyone's interested in that, feel free to ask. But it is worth not having MySQL read data that it's not going to use. And then also, excuse me. When we first started on this scalability project, our database was enormous and it was growing at an alarming rate. And our CTO and a couple of the other engineers at the company came up with classes of data that should get removed from the database. A good example is log-like data. When you're at a smaller company, it makes sense to try to keep everything in, or not company, but software, and everything can fit in one database. It makes great sense to have everything in that database so you can query it the way you're used to. You can use all the ORM stuff that you're used to. But for us, that was a liability because it meant that we were putting this data that MySQL is not really good at dealing with anyway in the database and just making it grow ridiculously. So that was just an example of something that we had to do to tread water, basically. To maintain performance, you have to monitor it. We use some software called Graphite, which has a front end of Grafana. This is actually complicated software. Graphite might actually be the front end. I think it's StatsD, which Etsy published like 10 years ago or something. There's a newer thing called Prometheus, but it's pretty similar. Those graphs that you guys saw before with the database CPU usage, that was actually Graphite. Graphite, it's really cheap for you to send little counters. So we actually can make we can page ourselves based on queries that you do against Graphite. It's got a weird query language, but basically we could say, like, if this thing keeps rising like a queue, page me. We also use Elasticsearch for our logs, which is kind of a love-hate relationship. but we can, thank you, we can query those logs, and I'll show a screenshot of that later. But basically, in our access log, I have added the actual count of database queries that we do in a request and the amount of time we spent blocking on the database. This is crucial information. Similarly, we did the same thing with DynamoDB, and that was really illuminating. No one actually had any idea how many DynamoDB queries we were doing for some of these pages, and when we knew, we learned something. And so this helped reduce queries. Actually, and if you go to that more link, it actually shows how we log those DBI counts. DBI actually makes this really easy, but I'd never seen how easy it could be done before. You can actually split up the counts based on whatever you want. So we actually log writes versus reads. If we wanted, we could do anything based on the SQL. Here's my, we'll do the memory one after. You might not be able to read this. I can't. But basically, this is a view of this morning. In 15 minutes, the pages that did the most queries. So right now, there's a page that does 824 queries, and it's blocking on the database for 12 seconds. That's too long. We need to fix that. I've like kind of had my eye off the ball with respect to this stuff lately because of some security stuff. But this, I can like in real time look at these things, sort by these columns, very handy. When I started, that number would have been 6 digits. We had some pages that would do tens or hundreds of thousands of queries in a page. We also didn't have the Reaper, so those pages may have just gone forever and the user might not have gotten their data back. No, access log is when, oh, sorry, thank you. He asked if access log was an application. So the access log is what you think. It's the access log for the web server. What we do is we have our Perl workers write JSON for their access log, and they write a boatload of data. They write like what user they were servicing. They write all of this data. It's probably something like 50 to 75 fields. And then it's, because it's JSON, it's really easy to ingest into whatever. Yeah, this is generated 100% from the access log. And you can see there's, I mentioned, let me go back just a second. So we do, we also did a lot of memory work to make it so that we could saturate servers more fully. When I started, I think we had 10 or 15 workers per server. Maybe it was 20. Now I think we're closer to 40. What we did was we actually had the Reaper look at the memory usage of each process. It's easy to see a process's RSS. That's like almost constant time, right? Does anyone here know how you get the shared and unshared memory on Linux? It's hard. It's an ON operation on how many mallocs the process has done. So it takes a long time. Like we're talking, for our processes, 30 or 40 milliseconds. That's slow. So basically, we made the Reaper periodically parse that data and reap a process if it has unshared too much memory. When I worked at my last job, I was mostly doing Windows. I thought that when I came to a Linux shop, suddenly memory usage would be easy and everything would be copy on write, and like that's a lie. That's like not how things work at all. Unsharing happens all the time. Part of it is because of reference counters. Yeah, reference counting. And so like those things need to be updated all the time. And so pages just get unshared. And it's really, really, really hard. And so in this access log, we have the RSS delta, which just measures the difference between the RSS at the start and the end. That's great because it gives us something. It is really not as much as we'd want because we don't have when something went unshared. Because we could have gone from 1 gig RSS to 1 gig RSS, but unshared 300 megs, and we wouldn't even know. So this is just like a super coarse-grained way to figure out memory problems, really the most egregious ones. But Perl just really does not give us what we need to dig into memory problems. So this is surprising to me. I thought that Nginx and Apache were basically the same. Oh, go ahead.
On the previous one, are you saying that looking up the Perl code used to parse
It is and has been. So fundamentally, the problem is that that file is called snaps, S-M-A-P-S, and it's got a line or a set of lines per malloc. And so, if you somehow figured out how to make your code malloc one time, it would be fast. But I don't know how you're going to do that in Perl. Maybe an alternate malloc, but then I feel like you're really getting into scary. I would suspect any language, any code not written in C or C++ would have the same problem. I suspect if you looked at snaps for Java or Python or Ruby, it would be the same way. What was? Right. Right. So he said that. Right. He said that in C and C++, anytime you don't know how much memory you're going to use, which is most of the time, you're going to malloc more. So just look at the file. I think you'll see that it can get really big for any process that's over, say, 300 or 400 megs. And ours are typically sitting around a gig with most of that shared. So. All right. So I thought that Nginx and Apache were basically the same thing, just a little different. Nginx was like new, so it had a different configuration model, but fundamentally they work differently. Apache is streaming. I would have thought that would have been better, right? Because it means that there's like no buffering happening or anything like that. But the problem is, we have 60% of our users are mobile, and so when I connect to a web server with this, and it's streaming, the web server is blocking until my phone finishes the request. And that's a huge, huge problem for any system where your user base is slow, right? So like that's going to be like anyone except for maybe APIs. So when we switched to Nginx, our service, we can handle a lot more users. In fact, I honestly think we should reconsider a lot of things because it's just a different model. And so that just surprised me because I mean, they seem so similar, right? It's just HTTP. But they're really, really not. And so I suspect that there are situations where Apache might be better, like you can't write to the disk or you don't have memory. But that seems really unlikely. So we have a couple pages on our site. If you've ever used ZipRecruiter, you may have seen that like you could look at a job, you can look at a listing of jobs. We call those SERPs, search result pages, and DERPs, directory result pages, and then there's the job page. The speed of those pages really matters because that's what we want Google to index, and that's what needs to be fast for the vast majority of people who use our site. We had an initiative that started 3 or 4 months ago where we said, all right, for these pages, we're willing to burn it to the ground and start over. Any engineer can have as much time, that is reasonable as they want to implement their own stack or use existing stacks in any language. And this is called a bake-off. I think that's a silly name, but whatever. And so like people submitted Go, people submitted Java. There were a couple Perl entries, some really heroic Perl code that used XS to parse URIs and stuff like that. That's David here. So anyway, we had Lua entrants. There was Haskell, there was C#. I don't think there was an Erlang. Anyway, so it was interesting seeing what could go really fast and what didn't. Probably could have, but didn't. Unfortunately, when we got to the next step where we had to say you have to be able to do multiple back-end API requests at the same time, Perl could not keep up. And so the results of the bake-off currently are Go. which is kind of exciting. Like, I think Go is cool, and I'm glad Java didn't win. It almost did. In fact, it was really cool. There's this younger engineer who sits catty corner to me, and he was like someone was working on Go, a really senior engineer who had a lot of work to do, and this younger engineer, he saw that Java had beat Go in the first running, and he was like, well, I guess I need to stay up all night and implement a Go version that's going to beat them because I do not want Java to win. And he did. It was really cool. It was really cool. So it's Jason Gowan. He's a smart guy. So anyway, that's been a really kind of sobering event, because we all love Perl, right? But to some extent, Perl is not the right tool for every job, right? There's lots of ways to do things. It is okay for us to have some part of our site be in another language. That's okay. We have a fairly good amount of Python at ZipRecruiter and Java, be that, whatever that means. But the stuff that regular engineers want to interact with should be sort of fun. And actually in the bake-off, we had a bullet point for joy. And I think, interestingly, there was something about Perl was the only language that did not have significant negatives from the managers, something like that. Does that sound right? Whereas every other language, Python, Ruby, Java, C, someone was like, I really don't want to write that. So I thought that was kind of interesting. So when you come, okay, I'm trying to think what's secret. Is Magic 5 a secret? Yeah. So when you post a job on ZipRecruiter and you say, you want people to look at that job, we have a process that will look at your job posting and look at our giant resume corpus, try to match them, reach out to those job seekers and say, hey, you should sign up for this job, with the hopes that you will get 5 job seekers in 5 minutes. And that is, that's a really cool thing, and that's in Java using some machine learning stuff, which means I don't know how it works. There's some other things, but they're kind of like ancillary R&D microservice type things. We have a team in Israel who mostly writes Java. So there's a little bit of Python coming out of there now. Okay, so what's next? The memory usage is still really high. And as I said before, that's really hard. There's not great tools to deal with that. Tim Bunce tried and failed to make, it's true, yeah, he had a talk 3 or 4 years ago where he was like, look at this. It's like NYT memprof. It's not called that, but something like that. And it would give you this stuff that you could dig in, and it was very alpha, and then it stopped. And it's because Perl just doesn't give the information that you need. So I don't know how we're going to resolve the memory usage issue. I suspect, maybe splitting the app up into microservices, but that's a whole lot of work to do on something that may not work. CPU usage is still really high. We didn't want to do this bake-off. We wanted to profile our code and make it fast, but we kind of had a death of 1,000 paper cuts kind of situation with the performance of our regular web app. I suspect part of that is that when you use many people here use Catalyst? 2. I suspect that's not really true. So Catalyst is really easy to put stuff in that will run for every request, and you put more stuff in, and you're like, hey, where should I do this? I'll just put it in the spot that runs for every request. And for us, a lot of stuff runs there. And even though we've done work to get it out, it's really hard to take stuff out and not break rarely accessed parts of the site, or maybe some of these things, they might not even error if some of the data is missing. They just assume that undef means something. So I don't know what that's going to mean. I suspect that a lot of our site will continue to be written in the way that it's written today. Hopefully the Go stuff is cool and fun enough that certain classes of pages will just get written that way. But I don't know. That's hard. So I finished really early. You might check out the SRE book. It's free now. It was free since I last did this talk. it goes over some of these things. It's written by Google, and so it's a pretty good book, and it's actually what gave me the idea to start adding counters for APIs. I would like for us to make that more generic instead of having to like I had to figure out how every single DynamoDB driver that we use works to count those things, and it's a lot of work. And I would like for that to be more automatic. But any questions? Jim.
Yes, you said that you use a wide variety of languages to express the application. With respect to the database itself, you only mentioned MySQL. And so two parts of the question. Do you have any insight into how the decision to use MySQL versus Oracle was made back in the day? And is it inherently the case that when you decide on a database, that's a much more fixed decision than is the decision of a particular program?
Yeah, so basically Jim noted that we use lots of languages, but I only mentioned one database. And then asked if, what was the first question?
What would do you have any knowledge as to how or why that decision?
Okay, why do we use MySQL,
First place.
and how easy is it to change databases, sort of?
Okay.
Yeah.
Okay.
Yeah, so a lot of ZipRecruiter code was written and chosen the way it was because it was tools that the founders knew how to use, and it's a startup, so they were willing to take on technical debt to make a business that works. And I would say that that has worked out in spades. That's why that was chosen. As for switching, I do think that it is harder to switch databases than programming languages or operating systems. But for what it's worth, we actually use a lot of databases. We use MySQL for our primary OLTP, online transactional processing database. But we also have multiple batch databases. Redshift is one of them. That's a Postgres fork that Amazon made. It's a columnar data store. We use DynamoDB. We use anything else that you guys can think of? Yeah, there's a few Postgres that Redis. Oh yeah, XDB. Yeah, that's a key value store that one of our engineers invented that uses LMDB. It's kind of cool, actually. But anyway, so yeah, I think that for us to switch, you know, a lot of engineers, myself included, have come into ZipRecruiter being like, we should switch to Postgres. This will be so easy. And that's just like a ridiculous proposition. To switch from MySQL to Postgres would be, I think, an incredible amount of work. Not just because MySQL has different dialects. At this point, we're depending on Aurora because MySQL cannot run as well as we can. Hold on. I know that there's a Postgres front end, but it's still using the MySQL backend, and so we would suddenly have performance differences that are artificial because of the Postgres front end, but the MySQL backend, which Aurora uses, would still work the same way. So I have, like, when we switched from MySQL to Aurora, there were a handful of things that suddenly got way slower because of the way that Aurora works. Can you imagine how that would be with Postgres? It would be an incredible amount of work just tuning it. And so I don't think that we could do it, even though I think it would be a lot of fun. Is there anything else? All right, that's what I thought.
I work in a very small operation. I'm someone from Robustness organization. So Scalability can 60 workers. Is there any reason why not just if any advantage table is a text field and put down use number of characters, it does not need to be joined or grouped. Just simply make that another database and programmatically fetch it by ID in the programming code.
So he was asking, why couldn't you basically store certain kinds of data outside of the database or in another database? Right. You can absolutely do that. To some extent, you are risking a level of consistency there because you do not have the atomic guarantees that a single database can provide. Like There is no way you're going to get the consistency in two databases and also have a situation where everything can talk to both at the same time. You should look up the CAP theorem, C-A-P. Basically, it's a really hard problem, and you can do it, but you're making trade-offs that you should be aware of. But I suspect we do that in some places. It wouldn't surprise me. Data that we're like we don't care about, we probably store in DynamoDB. Yeah, okay, so David Farrell, who works at ZipRecruiter, asked about, I mentioned that sometimes DynamoDB or S3 have like gone down. But he mentioned that sometimes we have these crazy outliers. DynamoDB, it's actually a pretty interesting system. The way that it works is your data is partitioned based on a key that you decide on, and all that data gets put into these partitions, which have these rules, like each partition has to be 10 gigs. If your data exceeds that, it gets split in half and never merged back together. If you ask for X amount of queries per second, they split the partitions and they never join back together. So one of the problems we found is that if your data is poorly keyed, it's easy to get hot partitions, right? But also implicit in the things that I mentioned before about the splitting and joining is that this is a really scary problem. If you had, say, I don't know, let's say you have 10 gigs of data, should fit in one partition, but you want to upload it now. So you crank up the write capacity on your table to something absurd. You do this, you upload your data in an instant, and every single piece of data is in its own partition. And so now, anytime you access one thing 2 times, you have a hot partition, and you're getting throttled. And that's obviously the absurd version, but this happens with not absurd stuff. So like the scary thing is Amazon's like their solution is just don't ask for I/O above what you will ever use. It's funny to me because DynamoDB is a key value store that's schemaless, but it requires more planning than a traditional database, because if you ever want to change something, you need to basically rebuild everything, and it can take a long time. But does that kind of answer your question? Okay. Nathan. Right, so he was asking, basically, you've got business logic in your ORM or some other model layer. How do you deal with that with multiple languages? So to some extent, excuse me, to some extent, these pages are already optimized to not have business logic in them, because they're already supposed to be really fast. The problem is because it uses the ORM, people slip something into a method for one part of the site, and suddenly this part of the site, which is supposed to take 10 milliseconds, takes 100 milliseconds because they've added some query. So to some extent, we avoid that. We avoid business logic. One thing that we're working on, we're not there yet, is certain parts of the business we are factoring into microservices, like the billing. The billing needs to be treated more carefully, and so it's going to be a separate like directory in. We have one giant monorepo in the repo, and it will be tracked more carefully. Every commit that goes into it, may have to be vetted by a set of individuals, and we'll see how that goes. I'm not sure yet. I have time for one more question. Go ahead. So he asked, he said, if there was a takeaway from this talk, it's that nothing is reliable, which I agree with. That's absolutely true. If you think you've got 100% uptime, you either are not monitoring properly, or seriously, or you just, well, that's really all there is, or you're just like not doing much.